Today we'll be tackling reaction stoichiometry. First, molar mass. Molar mass is the mass of 1 mole of atoms of a pure element in grams. It is numerically equal to the atomic mass of that element. Its units is grams per mole. To get the molar mass of elements, you just need to look at the periodic table and its atomic mass. That is the molar mass of an element. However, for compounds, you need to get the molar mass of each element in the compound. For example, hydrogen in H2O has 2 hydrogen, so you multiply it by 1.01, its atomic mass in the periodic table to get 2.02. In water, you only have 1 oxygen, so you have 1 times 16, its atomic mass, and after that you get 16. You then add up 2.02 and 16 to get 18.02. Thus, 18.02 gram per mole is a molar mass of water or H2O. For another example, we have calcium nitrate. So we need to get the individual elements in this compound. We have calcium, which there's only 1 calcium, and its atomic mass is 40.08. So we have 40.08. And for nitrogen, since this is inside the parenthesis, you need to multiply it by 2, or the number outside the parenthesis, which is 2. So we have 2 nitrogen in this compound. So we multiply it by 2 times 14.01, which is the atomic mass of nitrogen, which results in 28.02. We also have oxygen. There's 3 oxygen inside the parenthesis. However, since there's 2 outside the parenthesis, we need to multiply them together. So we have 6 oxygen. So 6 times 16, the atomic mass of oxygen, which results in 96. Add them all up together, and we have 164.10. 164.10 gram per mole is a molar mass of calcium nitrate. Next is percent composition. Percent composition basically measures how much of that element is in the compound. Using H2O as an example, the formula for that is, let's say we're getting hydrogen. So the formula for that is percentage of hydrogen equals mass of hydrogen over mass of water times 100. So we have 2.02, which is the mass of hydrogen in the compound, and 18.02, which is the mass of water. We multiply it by 100, which equals 11.21% hydrogen. Next is for oxygen. Percentage of oxygen equals mass of oxygen over mass of water. Mass of oxygen is 16, and the mass of water is 18.02. We multiply by 100, and we get 88.79% oxygen. Always remember that we need to add up the percentage of all the elements in a compound. They must add up to 100%. And for our next example, we have calcium nitrate. We need to figure out the percentage of oxygen in this compound. So, the mass of oxygen in this compound itself is 96. And for the compound, calcium nitrate, its mass is 164.10. We multiply by 100 and we get 58.50% oxygen. This is the percentage of oxygen in the compound. For the mole and Avogadro's number, 1 mole is equal to 6.022 times 10 raised to 23 particles. Avogadro's number is this value, 6.022 times 10 raised to 23. And for particles, you can think of it as like a placeholder. It can mean atoms, molecules, ions, or formula units based on the given situation of your problem. For our practice problem, we have how many moles of atoms does 190 grams of iron contain? So, the molar mass of iron is 55.85 grams per mole. For this problem, you can use 2 unit factors, either 1 mole of Fe or iron over 55.85 grams of iron, or 55.85 grams of iron over 1 mole of iron. The unit factor we will be using is 1 mole of iron over 55.85 grams of iron. So, to get the mole of iron, we have 190 grams of iron times 1 mole of iron over 55.85 grams of iron. Because we use this unit factor, the grams will be cancelled and we will be left with the mole. So, once we calculate this, we have 3.40 moles of iron. For the next problem, how many ions are contained in the iron? This is where Avogadro's number will come up. To get the number of ions in the iron, we multiply the moles we have gotten, which is 3.40 moles of iron, with the unit factor of 6.022 times 10 raised to 23 iron ions over 1 mole of iron. Since we use this unit factor, the moles would be cancelled and we will be left with the ions of the iron. So, once we calculate this, our final answer is 2.05 times 10 raised to 24. For the next problem, how many moles are there in 1,500 grams of water? Since this is a compound, we need to first find out the molar mass of the compound. So we have 2 hydrogen times 1.01 and 1 oxygen times 16, which results in 18.02 grams per mole. We multiply the given value of 1,500 grams of water with 1 mole of water over 18.02 grams. After calculating, we also cancel the grams, we get the value of 83.24 moles of water. So, the next problem is, how many water atoms? With the moles we have gotten, which is 83.24 moles of water, we multiply it by 6.022 times 10 raised to 23 water atoms over 1 mole. The mole will be cancelled by using this unit factor and we will be left with 5.01 times 10 raised to 25 water atoms. Next is empirical formula. Empirical formula is also known as the simplest formula. It is the smallest whole number ratio of atoms in a compound. We will use the example of a compound that contains 26.6% potassium, 35.4% chromium, and 38% oxygen. Because it is in percent composition, we multiply it by 100 grams over 100%, which results in 26.6 grams of potassium. Basically, we just convert the percentages into grams, so 35.4 grams and 38 grams. We then convert it to mole as well, so 26.6 grams times 1 mole over 39.10 grams, so then 0.680 mole, 35.4 grams of chromium times 1 mole of chromium over 52 grams of chromium equals 0.681 chromium mole, 38 grams of oxygen times 1 mole of oxygen over 16 grams, which results in 2.38 mole of oxygen. After that, we have to divide all these moles by the smallest value. By looking at this, 0.680 is the smallest value of the mole. So divide all these moles by 0.680. 0.680 divided by 0.680 equals 1. 0.681 divided by 0.680 equals 1. And 2.38 divided by 0.680 is 3.5. Because it is in decimal form, we need to convert it into whole number form. Think of the smallest integer that when you multiply it by 3.5 results in a whole number. If the number you thought of is 2, then you're correct. 3.5 times 2 results in 7. It is now a whole number. However, you also need to multiply the other numbers or atoms by 2. So, 1 times 2 of potassium results in 2. 1 times 2 of chromium results in 2 as well. And you have 7 of oxygen atoms. The empirical formula would then be K2Cr2O7. Molecular formula. Molecular formula is also known as the true formula, which is the actual number of atoms present in a molecule. So, we will use glucose as an example for our problem. 1 mole of glucose, C6H12O6, contains 39.99% of carbon, 6.73% of hydrogen, and 53.28% of oxygen. We will then use the steps we used earlier in empirical formula where we convert the percentages into grams and then we convert the grams into moles. So, we have 3.33 moles of carbon, 6.66 moles of hydrogen, and 3.33 moles of oxygen. After that, we then divide it by the smallest number of the mole, which is 3.33. So 3.33 divided by 3.33 equals 1, 6.66 divided by 3.33 equals 2, and 3.33 divided by 3.33 equals 1. So, the empirical formula of glucose is actually CH2O. However, this is not the end. We need to get the molecular formula. To get the molecular formula, first, we calculate the molar mass of the glucose or the empirical formula of the glucose. So, we have 1 carbon multiplied by 12.01, which is its atomic mass, results in 12.01. We have 2 hydrogen multiplied by 1.01, which is 2.02, and 1 oxygen multiplied by 16, which is 16. Add them all up together, and we have 30.03 grams per mole. Now, we divide the given molar mass of glucose, which is 180.18, with the molar mass we got earlier of CH2O, which is 30.03. So 180.18 divided by 30.03 results in 6. This means we will multiply CH2O by 6. It will result in C6H12O6. This is the molecular formula of glucose.